Hi, this is Dr. G. Vikas Paul. In this session, we'll see a problem. For the simply supported beam shown in the figure, find the slope it support A maximum deflection using moment area method. So, using moment area method, we need to find the slope at A and maximum deflection. So, this is the problem given. Simply supported beam A, C, D, B, I, 2I, I, and point loads and spans are given. We need to find theta A as well as maximum deflection. So first, using moment area method, first of all we need to find the reactions RA RB using sigma Fy equal to 0 and sigma moment about A equal to 0. So sigma moment about A equal to 0. So 50 into perpendicular distance plus 70 into perpendicular distance minus RB into perpendicular distance. From here you can find RB. Sigma Fy equal to 0. Upward forces equal to downward forces. RA plus RB equal to 50 plus 70. From here we can find RA as we know RP here. Yeah. Now we need to draw the bending moment diagram. So to draw bending moment diagram, we know the procedure. First of all, we need to calculate bending moment values. First, I have taken section between this dB at a distance of x from B. So bending moment at this point is 65 into x. Right side anti-clockwise. So we are coming from opposite end, therefore plus 65x. At B, substitute x equal to 0, it is 0. At D, x equal to 10 meters, therefore 650. Next, I will take section between C and A at a distance of x from D. In this way, we can calculate the bending moment values and we can draw the bending moment diagram. Now, this is the bending moment diagram 650, 550. Okay, at C, 650, 550, at D, 650. Now, let us draw M by A diagram. So here it is I, 2I. So here as it is 2I, the value comes down. So 552, here what is the value? 550 by E into 2I. That will become 275 by EI. Here 650 by E into 2I. It will become 325 by EI. So 650 by EI, M by EI diagram. Okay. Now, first of all, we need to calculate support at theta A. So theta A I need to calculate. Further, so this is a deflection curve. Okay, and let us draw a tangent at A, tan A, and if I extend this line, it will be B B dash. Okay, and this B B dash is also called as tan B by A. Tan B by A means tangential deviation of B due to tan A. So tan B by A equal to B B dash. Okay, and from this figure theta A equal to B opposite by tan theta A or theta A equal to BB dash by L. Okay, now tan B by A equal to, what is tan B by A? Tan B by A according to the definition, it is the AX bar by AI, EI. So AX bar about B, because deflection we need to find at B. So AX bar by EI. Now if we find this value, we can find theta A. This is nothing but this one. This is nothing but this one. Okay. Now we need to calculate area of M by A diagram into X bar. Okay. Now tan B by A equal to, now area I am calculating. So first of all, I am calculating the area, and from B I need to calculate X bar. So I have divided it into four parts. First part, second part rectangle, again third part triangle, and fourth parts. Okay, first this one I am calculating this area. So half into 10 into 550 by EI into perpendicular into X bar is this one. This is 10 by 3 and this is 30. This is completed. First portion is completed. Now let us see second portion. This rectangular portion. Area is length into breadth, 20 into this 275 by EI. Okay, 275 by EI. Now into 20 by 2 plus 10. Okay. Next this area, which area? This area. Okay. Now half into base, 20 into height. Now what is this height? This height is nothing but 325 minus 275. 325 minus 275 is this height. okay, into what is the perpendicular distance. Now what is the x bar? 10 plus 20 by 3, 20 by 3 plus 10. Okay, now last one, final one, this one, half into base 10 into 650 by a into 2 by 3 times 10. If we add all this, we'll get tan b by a as this value. So theta a equal to tan b by a by divided by L. So this value divided by L is nothing but 40. So therefore this is theta a. Theta a is over. Next we need to find the maximum deflection. So how to find the maximum deflection? We know that at a point of maximum deflection, the slope of elastic curve will be 0. That means this is a deflection curve. Suppose if it is a maximum deflection, E is a point, we are assuming there is a maximum deflection. Now at this point, if I draw tangent, okay, here the slope will be 0. That means tan E will be 0. Okay, tan E will be 0 and slope also 0. So theta E is 0. That means theta E is 0. Okay, now let me draw a tangent at A, tan A. If I draw here, it will be tan E. Okay, now if I take A and T up to this portion, half portion, theta A minus theta E is equal to theta E by A. Okay, now theta E by A is equal to theta A, I can write, because theta E is 0. Theta E is 0. So I can write this one, theta E by A equal to theta A. Now let the maximum deflection be E at a distance of x from C. Now let this E be at a distance of x from C. X from C. Now we need to find this x. We need to find x. Now theta, let's take this theta E by A. Now what is theta E by A? It is nothing but area of M by A diagram. Okay, A by M by E. So area of M by EI, area by EI, or we can call it as area of M by EA diagram, or A by EA. From Moore's first theorem, theta equal to A by EI. That is what we wrote here, A by EI, or we can say area of M by EA diagram. Okay, now this is the M by EA diagram we know. Okay, this area we need to calculate now, theta E to A, this half area, this portion area. If we calculate this one, we have these two portions, we can divide it into three portions. Okay, the first portion is this one is this 10 550 by A. So half into 10 into 550 by A. Only area here, no x bars, because it's just theta. Okay, next this area, this one, this rectangle, okay, area. So this is x, right? So x into this one plus plus now this one, take this portion. Here we don't know what is y value. To calculate y value, we are applying one similar triangle formula here. From similar triangle, if we extend this, okay, 50 by EI divided by 20 is equal to y divided by x. From here y equal to 50x by 20 EI. So y equal to 50x by 20 EI. So half into x into 50x by 20 EI. Okay, now so this is your theta E by A, but theta E by A equal to A. Okay, so theta E by A equal to A. So I am equating this to theta A, already we have found here. Okay, so I have equated this. From here it is, we can find x in this way. It is roots. So this is your figure, right? Delta max. Now x value is 10.55. Okay, if I draw a tangent here, now it is called as, this deflection is called as tan A by E. Tan A by E. Now this is nothing but your maximum deflection. Okay, so if we calculate this, it will be a maximum deflection. Now tan A by E is nothing but AX bar by EI. Between A to E, about A, because here this deflection we are calculating, therefore about A. So tan A by E is equal to, now this portion M by A diagram, we need to calculate area into x bar. So this area, okay, into x bar, see, x bar plus now this portion, this portion, rectangle portion. Okay, area into x bar 10.55 by 2 plus 10. Now this portion, okay, area half into base into height. What is height? 5x by 20 we have calculated now here. So x is nothing but 10.55 now. So x by, now this is 10 plus 2 by 3 into 10.55. 2 by 3 times 10.55. Okay, and if we add all this, we will get this value, which is nothing but delta max. Similarly, let us see other problem using momentarium method, overhanging beam problem. How to solve it? Let us see. An overhanging beam with UDL is shown in the figure. Find the slope. So an overhanging beam with UDL is shown in the figure. Find the slope at theta A we need to find, theta B we need to find, and deflection at C, YC we need to find using momentarium method. Let us first find the reactions. So we know how to find the reactions RA, RB using sigma moment about A equal to 0 and a sigma Fy equal to 0. If we apply using these two equations, we can find the reactions. Now we need to draw the bending moment diagram. So how to draw bending moment diagram? First I have taken a section XX, bending moment at any section XX between BC equal to minus 10x, then at C x equal to 0, substitute x equal to 0, at B substitute x equal to 5 meters. Similarly, next take here from here I have taken, anywhere we can take x. In this way we can have taken, and this is my bending moment diagram as well as M by EA diagram, because here I values are same. Here it is not mentioned two different I values. I values are same here. Okay, therefore this is my M by EA diagram. Okay, now I need to find deflection at C. Let us find deflection at C first. Okay, that means if you see this figure, this is the deflection curve. This is the deflection curve. This is C dash. C dash equal to delta C. This delta C we need to find. Okay, so delta from here, from figure, if I draw tan A, tangent at A here, it will be C dash. If I draw tangent at B, this will be the line. Okay, this will be the line tan B. Okay, the angle between tan B and tan A, let it be theta B by A. Theta B by A is the angle between these two lines. Okay, let this distance be height. This one by tan B by A. Tan B by A. Okay. Okay. Now, what is this total height? It will be tan C by A. Tan C by A. This will be tan B by A. This will be tan C by A. Okay. Now delta C is equal to tan C by A minus C dash. We can write total length minus this height. Now first of all, let us calculate tan C by A, then let us calculate this. So tan C by A I am calculating, which is nothing but AX bar by EI. Okay, C and A. So for this M by A diagram, we need to calculate AX bar by EI, X bar about C. X bar about C, because deflection is at C only. So first of all, area I am taking this portion and this portion. Okay, first this portion area is 1 by 3 times 5 into minus 1 by 125 by A, because it is parabola. Okay, parabola into this is x bar 3 by 4 into 5 plus area of triangle half into base into height 5 into minus 125 by A into 5 by 3 plus 5. Okay, this is 5 by 3 plus 5. Okay, 5 by 3 plus 5. This is correct, not this one. Okay, this is 5 by 3 plus 5. Okay, 5 by 3 plus 5. Then you will get tan C by A value as this one. Now I need to calculate CC dash. This is over. This we need to calculate. For this I am taking a triangle, the whole triangle. This is the overall triangle ABC, theta A, tan B by A, okay, CC dash. From here, similar triangle CC dash by total length is equal to tan B by A divided by this length. Okay, so CC dash we can calculate 2 times tan b by a. Now we need to calculate tan b by a, and 2 times this is a value. So tan b by am x bar by ei, which is equal to yeah, half into, so between b and a is enough. So this is m by in m by a diagram, this is between a b and a, this is m by a diagram between b and a. So half into 5 into minus 125 by a into 5 by 3 times b. Okay, from b we are calculating x bar. Why? Because the deflection is at b only. Okay, so from here we got this value. 2 times of this value is this one. Now I have substituted in the formula delta c equal to Tc by m minus c. In this formula I have substituted. Okay, now I got delta c. So deflection at c is completed. Next we need to calculate theta a. From this figure AB, in this figure theta a we can write T b by a by 5. So already with this value we know divided by 5, theta a is over. Now theta b we need to calculate, means theta b by a equal to a by ei. Okay, so a by ei means this area, if I calculate, that is done. This is a theta b by a. Theta b by equal to theta b minus theta a equal to that means theta b equal to theta b minus a minus theta a. This already we have calculated. This also we calculated. So theta b is also over. Thank you.